in this example, we're going to be, again, using that trick of dividing, or excuse me, of multiplying by 1 over x. But this time we're going to be dividing by, we're going to look for the largest power of x in the denominator and divide by 1 over x to that power. And we can do that because we're using this new rule that we've learned, this new limit law for limits at infinity. So if you have infinity, if you start plugging in infinities into your x's in the numerator and denominator, you're just going to end up with a mess of sums and subtractions of infinities, which really don't make much sense. So we use this rule of multiplying by 1 over x raised to the highest power of the denominator. And look what happens when we do that. Everything, all the other terms except for the leading terms in the numerator and denominator are going to go to 0 as x goes to infinity, because they all have x to a power in their denominators. This is going to end up going to 4 over 1, which is just 4. So these limits can get a little tricky because they can, even though you use limit laws, you can still end up with something that doesn't make sense. So for instance, in this prior example, if I just started plugging in x values here, as I said before, I'd end up with infinity over infinity or some combination thereof. And remember, infinity is not a number. That is what's called an indeterminate form. Here's an example of a problem where this shows up again as well. So if you look at this problem, x is going to negative infinity. I have this radical sign and then this additional term here. If I follow the limit laws, which do apply here, and bring in the limit inside the square root, because remember, this is law 8 I'm using. I can pull that limit in. And then I can use the sum rule under the square root. And then if I plug in infinities for these x's, I get this stuff. And what is that? I don't know. What's infinity minus infinity? It's not a thing. It's not defined. So we need to approach this another way. And we're going to approach it again using this new law that we learned. So as is often the case when you have a radical plus another term, we are going to multiply by the conjugate. So we're going to multiply by 1 in the form of the numerator and the denominator of a function being the conjugate of this guy that we're given. And I do that, the radical is eliminated in the numerator, and I end up with 3x in the numerator. And now I have a denominator. So again, I have x in every term. I can't just go plugging in an infinity. I'm going to use that trick. So the highest power of x in the denominator is actually just x. It's not x squared, because notice this x squared is underneath this square root. So I'm going to use that trick again of multiplying numerator and denominator by 1 over x. But we need to be careful here, because notice that x is going to negative infinity. So because x is less than 0, we need to remember that the square root function is always going to return a positive value, right? So the square root of x squared is always going to give me positive x. That's always the range of the square root function. But here our x's are all negative because we're going to negative infinity. So to have the equivalent of dividing by x, we're going to divide this radical term by negative square root of x squared. And then this other term we can just multiply by 1 over x. So this first term in the denominator can be simplified to be negative square root of 4 minus 3 over x. This term is negative 2. So this evaluates to minus 3/4. So this bit is tricky. You need to be careful when x is going to negative infinity, especially when a radical is appearing in your function. Because if you use this trick, you have to remember that the square root of x squared is always returning a positive value. And you're going to need to negate it if you have a limit like this.